In the last section of Chapter 6, we're going to talk about the properties of kites and trapezoids. So a kite that you would fly in the air is the same thing as the geometric figure. A kite is a quadrilateral with exactly two pairs of congruent consecutive sides. What that means is that the consecutive sides are congruent. For example, segments AB and AD are consecutive and congruent. The same thing is true for segments BC and DC. This would be called kite ABCD. So we have two theorems here about the properties of kites. Here they are. If a quadrilateral is a kite, then its diagonals are perpendicular. So you could just say as your reasoning, a kite has perpendicular diagonals. Or you could say the diagonals of a kite are perpendicular. If a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. Only one pair. So you could say that one pair of opposite angles are congruent in a kite. So notice here that in this case, angle B and angle D are congruent. Angle A is not congruent to angle C. Here's a problem solving example for example number 1. Alicia is using a pattern to make a kite. She has made the frame of the kite by placing wooden sticks along the diagonals. She also has cut 4 triangular pieces of fabric and has attached them to a frame. To finish the kite, Alicia must cover the outer edges with a cloth binding. There are 2 yards of binding in one package. What is the total amount of binding needed to cover the edges of the kite? How many packages of binding must Alicia buy? So we need to actually look through this problem and figure out what do I need to do. Well, since I need to know how much binding is needed to cover the edges, I have to find all of the edges of this kite. Being that I have 4 right triangles and I have 2 of the 3 sides, I have to use Pythagorean theorem. So let's start with length PQ. Length PQ, I'm going to have to use 16 squared plus 13 squared equals, well, it'll be PQ squared, but C squared. So 16 squared plus 13 squared gives me the square root of 425 equals C. And if I simplified that, I would find that the length of PQ is 5 root 17 inches. RQ is going to be the exact same thing. So RQ would also be 5 times the square root of 17. Now, if I find RS, PS and RS are the same thing. So I would take 16 squared plus 22 squared equals C squared. If I added the sums of the squares and took the square root, it would give me the square root of 740, which gives me 2 root 185. So each of these would be 2 times the square root of 185 inches. Now the reason why I'm not actually going through and putting these as decimals and rounding is we always run around at the end, get the best answer that's approximately what we should have. So if we add together all of the sides, 5 root 17 plus 5 root 17 plus 2 root 185 plus 2 root 185, you would get approximately 95.6 inches. Now, being that we have 2 yards, so one package contains 2 yards, 2 yards is equal to 72 inches. Well, if I have 95.6 inches, I'm going to take 95.6 divided by 72, and you can just think of this in your head anyway, because if each package comes to 72 inches and 95.6, I'm going to have to buy 2 packages. If you divide, you get approximately 1.3 packages. Well, you can't open up a package and take some out, so my final answer, you would need 2 packages of binding. So example 2. Example 2 is using the properties of kites. We want to find the measures of each of these angles. So we know that in this kite, the measure of angle FEJ, which is this angle right here, is 25 degrees. The measure of angle FGJ, which is this angle, is 57 degrees. Find each measure. So the measure of angle GFJ. So let's start there. The measure of angle GFJ. Well, we know the measure, I'm going to blow this up here, FJG. We know that their diagonals form 90 degrees. So we know that's 90 degrees. Well, if this angle is 57 degrees, we know that the triangle sum theorem says they all add up to 180. So because this is 90, we know these two have to add up to 90. So 90 minus 57 would give me the measure of angle GFJ as 33 degrees. The measure of angle JFE, so JFE. Once again, we know that this is 90 degrees right here. So this side, 90 degrees, this is 25. So 90 minus 25 would give me 65 degrees. Now I've inserted here the actual work if you needed to prove it to me. So you would say, for example, the measure of angle FJG is 90 degrees because the diagonals of a kite are perpendicular. Then we could say that the acute angles added together equals 90. The reason is acute angles of a right triangle are complementary. By substitution and by subtraction property, we find our answer is 33 degrees. The same set of steps would also work for part B. Now in part C, we need to find the measure of angle GHE. Now we know that in a kite, we have one pair, which are these two, of congruent opposite angles. So the opposite angles, one pair here, they're congruent. So we know from the previous one, we found these two angles. Well, 65 plus 33 gives us 98 degrees, so therefore this one has to be the same, which is 98 degrees. If we proved it, we would say that the angle GHE is congruent to angle GFE because one pair of opposite angles are congruent in a kite. The measure of angle GHE would be equal to the measure of angle GFE because of the definition of congruent angles. By the addition postulate, we could say the measure of angle GFE, which is right up here, is equal to the measure of angle, these two angles added together by the angle addition postulate, and therefore the measure of angle GHE is 98 degrees because of substitution. So now we're going to talk about a trapezoid. A trapezoid is a quadrilateral with exactly one pair of parallel sides. Each of the parallel sides are called the base. The non-parallel sides are called the legs. Base angles, so these two are base angles, and these two are base angles. Since we have two bases, we have two sets of base angles. So the base angles of a trapezoid are two consecutive angles whose common side is a base. So these two cannot be base angles because they're not on the common base. So angle A and angle D are base angles, and angle B and angle C are base angles. If the legs of a trapezoid are congruent, the trapezoid is called an isosceles trapezoid. The following theorems state the properties of an isosceles trapezoid. So here are your theorems based on isosceles trapezoids. If you have an isosceles trapezoids, that means each pair of base angles are congruent. Remember, an isosceles trapezoid on all of these will state that we have one pair of opposite sides that are parallel, and the legs are congruent. If a trapezoid has one pair of congruent base angles, then it's isosceles. So this one says that if you know that you have one pair of base angles that are congruent, then it will be an isosceles trapezoid. Notice though that we have to know first that it's a trapezoid. And lastly, if you have an isosceles trapezoid, that means the diagonals are congruent. But it also is a biconditional. And remember, a biconditional statement is true both forward and backwards. So we could also say that if we have diagonals that are congruent in a trapezoid, then it's an isosceles trapezoid. In example A, we're going to find the measure of angle y by using the properties we know of isosceles trapezoids. So the measure of angle y is right here. Now this is where you're going to have to remember things from a while back. You'll remember that the measure of angle x and the measure of angle w are same side interior angles. These are parallel. So these have to add up to 180. So we know then this would be 63 degrees. And then we know that base angles are congruent. So we know the measure of angle y would also be 63 degrees. Now, if you actually wrote out all that work, you would write this. By the same side interior angles theorem, you would say that the measure of angle w plus the measure of angle x is equal to 180. You would substitute in and then solve for the measure of angle x. Then you would say that the angles y and angle x are congruent because base angles are congruent in an isosceles trapezoid. Then, by definition of congruent angles and substitution, you would say that the measure of angle y is 63 degrees. In part B, we know that RT, which is the diagonal, is 24.1, and that QP is 9.6. We want to find PS. Well, since we know that the diagonals are the same in an isosceles trapezoid, RT is 24.1, the other piece right here, this QP, is 9.6, so 24.1 minus 9 6/10 would give me an answer of 14.5. So we know PS is equal to 14.5. If you wrote it out, it would look like this. Segments QS and RT are congruent because of if we have an isosceles trapezoid, their diagonals are congruent. Definition of congruent segments and substitution would say that QS equals 24.1. By the segment addition postulate and substitution and subtraction property, you would get the answer as 14.5. In example 4, we're going to apply the conditions for isosceles trapezoids. Find the value of y so that EFGH is isosceles. Well, we know that base angles are congruent, so we know angle E is congruent to angle H, and their measures are equal, so by substitution, we would say that 2y squared minus 25 is equal to y squared plus 24. If we solve, that would give me y squared, if I subtract y squared on both sides, equals 49, and the square root gives me positive and negative 7. If I plug both of those in, 7 squared times 2 minus 25, and negative 7 squared times 2 minus 25, and the same thing over here, they would both work. So my answer is both positive and negative 7. In the second example, JL is equal to 5z plus 3, KM is equal to 9z minus 12. Those are both the diagonals. So since both diagonals are equal in an isosceles trapezoid, their lengths are equal. So by substitution, I would plug them in. I would solve. And so the value of z would be 3 3/4. All right, the next thing we're going to talk about is the midsegment of a trapezoid. Now, the midsegment of a trapezoid is similar to the midsegment of a triangle. So the endpoints right here of each of these legs are connected by a segment. That is called the midsegment. So this is similar to the triangle midsegment theorem. If we have the midsegment of a trapezoid, the midsegment is parallel to each base, and its length is 1/2 the sum of the lengths of the bases. So to find the length of xy, you would take half of the sum of the other bases, which would be BC and AD. Here's our last example to show that. If I wanted to find ST, we know that the midsegment is 31. That's equal to half of the sum of ST and RU. So the trapezoid midsegment theorem, we would write that down. We would substitute in our two values, and we just solve. So I can multiply both sides by 2, and then use subtraction property, and get the measure of ST as 24. Now, I would assume you'd know most of these anyway, but the base legs and base angles, make sure you know those three based on the trapezoid. And then make sure you know the isosceles trapezoid and the midsegment of a trapezoid.